In this video, we're going to talk about the discriminant. The discriminant is the part of the quadratic formula underneath the radical. The value of the discriminant determines the number and nature of the roots you will get when solving a quadratic with the quadratic formula. So take a look at our formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. The part of our formula that is the discriminant is just b squared minus 4ac. Now, once we find the discriminant, there are four possibilities for its value. The discriminant can equal 0, and then you would have one real rational root. It can be a negative number, any negative number, and then it would have two complex roots if we were to solve using the quadratic formula. The discriminant can be positive and a perfect square, like 16 or 9 or 25, one of those numbers. And then we know we would have two real rational roots. Or it could be positive but not a perfect square, like 12 or 30, for example. And we would have two real irrational roots when we solve. So let's do a few examples. Example 1, we have 9n squared minus 3n minus 8 equals negative 10. We first need to move the negative 10 to the other side so we have everything on one side in standard form. So if I add the 10 to move it to the other side, I end up with 2. And so we have a is 9, b is negative 3, and c is 2. And then we want to use our discriminant formula, b squared minus 4ac, and plug in our b, a, and c. So b would be negative 3 squared minus 4 times a, which is 9, and c, which is now 2. And then we just have to simplify and figure out what the value would be. So that would be 9 for negative 3 squared minus 4 times 9, which is 36, times 2, which is 72. And then 9 minus 72 would be negative 63. So our value of our discriminant, I'm going to move that up a little bit so I can write underneath there, is negative 63. But then we need to state the number and nature of the roots. So this is a negative discriminant value. So let's go back to our chart for a minute. Any negative value of our discriminant means we will have 2, so that's the number of our roots, and then they are complex roots. So we will have 2, and they will be complex roots. All right, let's look at number 2. So first we need to get everything on one side in standard form. So we have negative 2x squared minus 8x, and then we need to add this 6 to the right side. So we have negative 14 plus 6 is negative 8. And then we got to pick out our a, which is negative 2, b is negative 8, and c is negative 8. And then use our formula. So our discriminant is simply b squared minus 4ac. And then we just have to plug in the b, which is negative 8, and square that, minus 4 times negative 2 for our a, and negative 8 for our c. So then we have negative 8 squared will give us 64, minus 4 times negative 2 times negative 8. So that would be 4 times negative 2, or negative 4 times negative 2 is 8, times negative 8 is negative 64, which simplifies to give us a discriminant of 0. So again, if we refer back up to our chart here, a discriminant value of 0 means we have one real rational root. So let's say one real root. All right, so those are the first two examples. Let's look at 2 more real quick. So number 3, we need to move everything to one side. So I'm going to move 7x and 9 to the other side and put everything on one side in standard form. So I get negative 6x squared plus 7x plus 3 equals 0. And then A is negative 6, B is 7, and C is 3. And then, just using my discriminant formula, so B squared minus 4AC is my formula. I plug in B, which is 7, so 7 squared minus 4 times negative 6 times 3. And that gives me 49 minus 4 times negative 6 is 24 times 3. Let's see, 24 times 3 would be 72. Yep, so 49 plus 72 would be 81, let's see, 121. And then 121 is positive and it's a perfect square. Because the square root of 121 would come out evenly as 11. So since it's positive and it's a perfect square, we have two real rational roots. So let's put that we would have, let me make it a little bigger, 2 real roots. All right, one more example. So let's first move everything to the side where 2x squared would stay positive. So over here to the left. So 2x squared minus 10x minus 5 equals 0. And then we have A is 2, B is negative 10, and C is negative 5. And we fill in our discriminant formula. So B squared minus 4AC would be negative 10 squared minus 4 times 2 times negative 5. And then we clean that up. So negative 10 squared is 100. Minus 4 times 2 would be negative 8 times negative 5 would turn out to be positive 40. So our discriminant is positive 140. So let's check up here. So it's positive, but it's not a perfect square. 140 is not a perfect square, but still positive. So we have two real irrational roots. So let's put 2 real roots. And then when we do the quadratic formula, we will talk more about irrational versus rational roots. But for now, we're just picking out 1 or 2 and whether or not it's complex.